Okay, it's number 4 from the AP Physics B 2011 exam. It's a fluid physics problem. We've got a beaker with given weight filled with water. We've got a ball in there that's anchored down. We know the density of the water. We know how deep it is, etc. And we want to know the weight of the entire apparatus. Well, the weight of the entire apparatus is the weight of everything. So the weight of the container, the weight of the fluid, and the weight of the ball. But we know the weight of the container. I'll just say weight of the, well, we'll say C for container, is 2 newtons. I know the weight of the ball, which I'll say WB, is 3 newtons. I don't know the weight of the water yet. And the weight of the water will equal the mass of the water times the acceleration due to gravity. I don't know the mass of the water, but I do know the density of the water. That's 1,000 kilograms per cubic meter. I do know the volume, 5 by 10 to the negative 3 cubic meters. And so, if I remember, density is mass over volume. And the mass of the water is density times the volume. Therefore, the weight of the water is the density of the water times the volume of the water times the acceleration due to gravity. So it's simply going to be 1,000 times 0.005 or 5 times 10 to the negative 3 times 10. I'm going to use 10 for the acceleration due to gravity. You're welcome to use 9.81. They're both fine. And you're going to get a value of 50 newtons, and that's simply the weight of the water. Ultimately, the weight of everything, or the net weight, or however you want to word it, total weight, will be the weight of all of it added together, so 2 plus 3 plus 50, or 55 newtons. And this is worth only 2 points. I've got to clean this all up. Okay, so for B, we want to do a free body diagram. Now the water is submerged underwater. It's got a rope pulling it down, so we've got tension down. It's got weight down. And it's got a buoyant force up. And we could have written weight as F sub G. And this is worth 3 points. You get 1 for each correctly drawn. You will lose points for anything that's not correct. So be careful. Don't draw anything extra in there. C, we want to know the buoyant force exerted on the ball by the water. Well, we're going to look at Newton's second law here. We're going to apply our dynamics. We're going to see that's in equilibrium, so the net force has to be 0. We've got an upward force of buoyancy pulling it up, and then we've got 2 forces down, tension and mg. And ultimately, we're looking for the buoyant force. I want to isolate FB. So FB has to equal tension plus the weight of the object. Well, I know a lot of this was given. Actually, I think all of this was given. Let's read this carefully. We know the weight of the object is 3 newtons. Yeah, we know the tension of the string is 4 newtons. So it ends up just being 4 plus 3, or 7 newtons. This was only worth 1 point. D, we want to know the pressure due to the fluid. We don't care about atmosphere, just the gauge pressure. Recall that the pressure due to any fluid is just rho GH. So the rho of the fluid, 1,000 kilograms per cubic meter. G, I'm using 10 meters per second squared still. And H is the depth of the fluid, which in this example is 0.2 meters. Ends up being 2,000 Pascal. Or newtons per square meter, whatever units you're comfortable with. .2 points. E, the string is cut, the ball rises to the surface. We want what happens to the water level. Well, you know, a lot of people think it's the same because the amount of water isn't changing, but it's not true. The water will lower. The The reason it's lowering is because it's no longer being displaced by the ball. Right now, the water had to rise. When the ball floats up, part of it will be submerged, but a good chunk will still be above the water. And that extra volume above the water is no longer displacing water. So the water volume and the height will lower as a result. And so, indicate lower, justify using the same terminology I just did, and you're going to get yourself 2 points. That's it.